Determine the elevation of top of an aerial pole from the following observations. Stations A, B and top of aerial pole are in the same vertical plane. The instrument is set at A. The staff reading and benchmark is given. It is 1.555 meters. Vertical angle observed to the top of pole from instrument A is 23 degrees 40 minutes. When the instrument is at B, staff reading on the benchmark is 1.155 meters and vertical angle to the top of pole from B is 14 degrees 20 minutes. RL of benchmark is given, it is 120 meters. The distance between the instrument set at A and B is 30 meters. The instrument is set at A and benchmark is 120 meters. On the benchmark, the staff reading observed is 1.555 meters and the vertical angle observed from A is 23 degrees 40 minutes. The instrument is shifted to 30 meters away and the instrument is set at B. The staff reading on the benchmark is 1.155 meters and vertical reading observed to the top of pole is 14 degrees 20 minutes. This is pole. This is top of pole. The distance between AB is 30 meters. Let us assume this is C, C dash, C double dash. The distance between instrument at A and the pole is capital D. This is the horizontal distance between A and pole. Calculate the distance between A to pole, that is capital D. This is A dash, this is B dash. Let's observe the figure. A dash, C dash and C is forming a triangle. From this triangle, tan 23 degrees 40 minutes is equal to, opposite is H1. H1 is the vertical distance between the instrument axis to the top of pole divided by adjacent is D, that is horizontal distance between instrument at A to the pole. Therefore H1 is equal to D into tan 23 degrees 40 minutes. Now take another triangle B dash C, C double dash. Tan 14 degrees 20 minutes is equal to, here the opposite is H2 divided by adjacent is the distance between instrument at B to the pole, D plus 30. Therefore H2 is equal to D plus 30 into tan 14 degrees 20 minutes. H2 is equal to tan 14 degrees 20 minutes is 0.255 D plus 30. H2 is equal to 0.255 D plus 30 into 0.255. 0.255 D plus 7.65. In the figure, if we observe the difference between H2 and H1 will give the difference between these two staff readings. So H2 minus H1 is equal to 1.155 minus 1.155. H2 minus H1 is equal to 1.555 minus 1.155. H2 minus H1 is equal to 0.40. Already we have calculated H1 and H2. Substituting H1 and H2 here, H2 we know 7.65 plus 0.255 D minus H1 is 0.438 D is equal to 0.40. 7.65 minus 0.4 is equal to 0.438 D minus 0.255 D. Therefore 0.183 D is equal to 7.25. D is equal to 7.25 by 0.183, that is 39.617 meters. This is the horizontal distance between instrument set at A to the pole. Substitute D value in H1 is equal to 0.438 D. H1 is equal to 0.438 into 39.617, which is equal to 17.352 meters. Now calculate the RL of top of the pole, that is C. RL of top of pole is equal to RL of benchmark. H1 is the vertical distance between instrument axis when the instrument is at A to the top of pole. The backside reading observed from A is 1.555 meters plus H1. RL of benchmark is 120 plus 1.555 plus 17.352 is equal to 138.907 meters. RL of top of pole can be obtained by using the staff reading observed from the instrument set at B. For that we have to calculate H2. H2 is equal to 7.65 plus 0.255 D. Substitute D here. 39.617. Therefore H2 is equal to 17.752 meters. Therefore RL of top of pole is equal to RL of benchmark plus backside reading taken from B is 1.155 plus H2. 120 is the RL of benchmark plus 1.155 plus H2 is 17.75. Therefore RL of C is equal to 138.907 meters.